right. All right, all right, all right. I'm coming on. Let me first get easy EDA up. And then I'll start the stream. All right. All right. We are back. What's up, y'all? I've got now a an intro screen. Oh, my hotkeys that I set for the intro screen also does tab switching in Chrome. So that is no bueno. I wonder if I do Alt Control 1, if that's better. Yeah, let's change these hotkeys. Yeah, I'll first put it I'll first put it on here first. I wonder, are you hearing my voice when I'm on my intro screen? I think you are. Anyway, yeah. See, still quite new to this. Trying to figure this out. Yeah. I'm gonna do, instead of Control 1, I'll do Alt Shift 1, maybe? No, Alt Control 1. Control Alt 1, Control Alt 2, apply. Okay. Yeah. So, okay. And then I should be now recording. Go back to the image, the screensaver, and then back to recording. Okay. I think that's that. So what are we gonna do today? Pretty much what we discovered last time is that a lot of these components are simply not placed in the correct spot. So for instance, these capacitors, they are decoupling caps that are supposed to be tied to this rail, the pins of this rail. And we found that a lot of the stuff like that, where these wanted to be close to the pins, were often never land somewhere. So, and there were several components that really exhibited this, and we had to move this SIM card slot, the component, up in order to accommodate these capacitors. And when you're moving components around like that, especially on a cramped board like this, it's not wise to be doing the routing at the same time. You really want to just focus on placement, making sure everything's in the spot that you want, at least generally, right? And from there, you start doing your routing. You don't want to have to undo a bunch of routing in order, I'm sorry. You don't want to undo a bunch of routing in order to move some components around and then redo the routing, only have to redo the routing later. Like, it's a big headache. So we want to put the effort up front in order to put components in their places. So that's what we're going to be doing. I think for the main ICs, these are fine locations. So, and also the SIM card. So we're going to keep that. But it's all these other components, these passives and stuff, that really we need to make sure that they're in the right spot in terms of proximity to pins and stuff like that. And a lot of them don't really matter that much, right? But let's just make sure that we're on the right track. So what I think we'll start with this component, Q8. Yeah, so this, where is it going to? All right, ESP32 enable. That should be going to the ESP32. Where's the enable? Oh, here it is. So the enable's here. It's going to want this. Okay, so then. All right. I think let's group the components together. I think that will be a good idea. So, for instance, this, we're going to group these two resistors next to them. So we're going to pull this off to the side, like so. I'm going to find these two resistors, R49. R48. And we're going to make sure that they're next to the pins that they want to be next to. Yeah, so we can put them like that and like this. Something like that. Okay. Now, where does it want to go to? Let's figure out where these rat lines go. Yeah, so this, does it just come loop back around? Yeah. So this just loops back around here. That pin doesn't matter too much, but it does go off to somewhere else. So this is going to go, what's R38? This a pull-up? ESP32IO0. This guy. So I'd want to go to this component here. Where is this? Where is this? Is it on the back side of the board? Yeah. Yeah, so it's close enough for that. Doesn't matter. Okay. Okay. DTR. Where's DTR going? Same connector. And RTS. Where's this going? Same connector. Okay. So these three are hanging out together. As well as this guy. Where's this going? Is this the same thing where it just goes? Okay, this is going to the ESP32. As well as that connector. All right. So let's take a look. Which pin is it going to? 27. Also, it's going to want, okay. Why are there so many pull-ups and pull-downs on this I/O? It's, what? What? That doesn't make any sense. I'm going to pull these components off to the side and ask the other guy what is going on here. This doesn't look right. All right, R39. Where are you? Yeah, you are going to be over here, off to the side. R38, same thing. We don't know what you're up to. R17. Also don't know what you're up to. C32. That's probably supposed to be there. Okay. C32 and C33. They probably want to be closer to the pins, but it doesn't really matter that much, I'd say. So where's pin 27? Is it convenient to put something there? Kinda. You can put something here. But I'm going to be conservative and just put it close to here. Just group them together. And if we find some spot later for it, then that would be better. But right now, we are not super concerned about this. I just got a text. Same thing with this guy. We'll just pull it close to there. Okay. And I believe that's everything that this circuit is tied to. We'll just keep it close to there, and then we'll place everything. So, yes, this is going to be connected to that, and then this is going to go off somewhere. A lot of it's going to come onto this side of the board, so we can route from there to there. Here we can go from there to there. Yeah, so this is, we can route it up through there. Where's this going? Same thing. Okay. Okay. We'll place these over here. We'll tighten this up. I don't want to move the connector. I don't want to move the connector. Just bring this over here. Bring this over here. Okay. Okay. So let's bring that in. Bam. Okay. R40. I forgot this one. Yeah, we can just put that as a pull up here or something. Yeah. Okay. That's that circuit. We can move this off to the side. I don't want to select bottom layer. Move this off to the side. Okay, we have that circuit. Now let's move on. Let's look at this circuit. R37, R36. Okay, where does this want to go? Why is it connected to VDD3P3 on both sides? What? What? This doesn't make any sense. So, okay, well, one of these is supposed to be... I don't know, man. Why are you pulling up 3DP3 to itself? This I'm also going to put in the what is going on bucket. Alright, R36. This looks more reasonable. Okay. Looks like it wants to tie to this component. What is this? Accelerometer. Okay, okay. So let's figure out where this wants to go. It's pretty much exclusively tied to the ESP32, so it makes sense that we put it close. What pins does it want to go to? ESP32 SCL. What is that? SCL SDA. Oh, I forget. I can just click on this net. Okay, that's probably what happens, that this got, it became 3P3 and it was supposed to be SCL? Yeah. Hold up. I suspect that's what happened. Um, Here, I'm gonna pull up. Yeah, I'm pulling it up on my other computer to share with these other guys. My other computer's Apple. I always forget how to do a screenshot. What's the shortcut? Shift Command 4. Okay, I'm telling him that looks like this is definitely a mistake of some sort. Okay, yeah, this is supposed to be STL. All right, all right. Okay, that's fixed. We can Alt I forward. Okay, okay. I might as well bring this up to him as well. Now that I'm at it. Uh, all right, we'll see. Okay, okay. So I cannot. I cannot be moving the SIM card away from where it was. Hold up. My buddy's sending me some PDFs. Download. Yes. Replace. Why isn't it showing up in my downloads folder? AOT. What is going on? Why is it saving it to my... Okay, whatever. All right, I'm going to email these documents to myself. Um, I'm going to email them to me, and I will be right back. All right, let's see if we can do this. Control-Alt-2. Did that do it? Control-Alt-1? Yeah, so that gets me to this guy. Okay. All right, sent the email. Let me open up my inbox, download these files. Okay. Looks like this is coming from A to I something. AOT, AOTI. Okay. Now I should be able to Control Alt 2 and come back on. Yeah, there I am. Okay. So AOTI. So these are the mechanical drawings. So which one? Okay. Okay, so we have different ODB containers available to us. And which one is the one that he's thinking of? AOT121A. Where is it? Where are you? Okay, we can look at these drawings. So I guess this is the SIM card slot, this is the USB port, and this is a power port. Is there, oh, there's more. Here we go. That's AOT121. It's probably the one that we're looking at. Okay, AOT121A. What is it? Attack on Titan? What? What is this? Attack on Titan. Yeah, this is more like it. So okay. Okay. I want to know which USB. Okay, okay. Are we going to be using USB A or USB C? Um, hmm. These look like it's USB A. Oh, uh, he's saying that we don't need the C, USB-C. Try just using USB-A standard model. Let me look this up. So what I'm seeing is that there's like 3 different models, right? And I don't know if one is more expensive than the other. They should be, right? Like if you scroll down, you have a bunch of comparisons, and so um battery life? What? Does this have electronics inside, or is this just a case? So this, what? This doesn't make any sense. What is this? This looks like it's just the case, so I don't understand what's going on. I don't understand what a lot of these advantages, disadvantages are. Yeah, this whole thing doesn't make sense. Um, but this does. This does. This actually gives information about the different connectors or the housings. So if we're gonna go to USB A, okay. So pretty much the whole board has to change shape. Whole board has to change shape. We are we're going further and further away from routing. We are now doing the mechanical stuff. That's okay. That's okay. Um, okay. How much space do we have? And how big is this already? It's right now it's 48 by 50 millimeters. This is in millimeters, so we have to shrink this way down. This is gonna have to shrink substantially. Oh, this is gonna be pretty tough. Pretty tough. Oh boy. Okay. All right, let's go to the 3D view. Okay. So the first thing that I see it's gonna have to change that probably this antenna portion has to come in. Like it has to be fully on board. It can't be hanging out here. So what is this connector? USB-C? No, this is yeah, this is the USB-C connector, and this is a debug connector. Um, yeah, the board's gonna have to shrink. 35. Maybe not so substantially as I was thinking. What is this? Yeah, so SIM card, USB, power jack. Right? I think that's what that is. Power jack. Does it say? This looks like it's just a power port. Um, okay. Now I wonder how it's supposed to AOT 121A. I don't want attack on Titan. AO tie. God. Why is it just all attack on Titan? Why is it all attack on Titan? Alright, maybe it's on DigiKey. What? Why didn't it? Okay. Alright, maybe ODB housing. Nope. Yeah, this is the only place I see it. I don't know if it actually comes with this. Could, but the drawings here that I see don't indicate that. This one it does. Also, this is not the right drawing. Oh, here we go. Here we go. Okay, here we go. We got a video. Let's check this out. This volume then, so that way you don't have to deal with that. Okay, let's take a look. Take a look. I sort of want to see the inside of one to see if maybe we'd be able to do double-sided component placement. All right. Here would be it. This is what yeah. So this one we'd be able to do double-side. All right, I'm gonna tell him that because our lives are gonna be a hell of a lot easier if we can do two-side placement. It looks like we can do two-side. Top and bottom placement with these boxes. Yeah, so that one we can't do it, probably. But like these box ones, it looks like we can in fact do double-sided, and all we have to do. Wait. Also, These look like they were cut. What? Is this gonna, how is it gonna fit onto here? So they're not cut. It's gonna be more like this. They're just bent a little bit. So how? There's gonna have to be like a an adapter that comes in to hit these. Maybe it's like, yeah, how would you do that? How would you do that? Don't tell me they listed every single car here. um, hmm. Hmm. Oh, it'd be like this. Maybe. Look at this. Oh, that's a cool connector. This is what we want. This would be what we want. So we get something like this. Oh, so this is what they have, where it's just, it's supposed to slot in, and then you just solder onto it. Okay. Does that make sense? Looks kind of thick for that. It looks kind of thick for that. Maybe it'll work. I don't know. I don't know. Yeah. Yeah, so if we can do top and bottom, that would be sick. That would be pretty sick. Yeah, like with this guy. But we just need to make sure that that's what it comes with. It doesn't really say. Yeah, I don't know what the actual inside of this is gonna look like on the inside, you know? Like, this is about as close as I get to figuring that out, is this video. And yeah, it might work. Might work. Where plugs in and you're fine. But I don't think these are the actual connectors. You know, the 121A. But regardless, it does seem like we're going to be able to route on both sides if we choose this. I'm going to tell my buddy that he needs to ask which male connector this this piece comes in. We might be able to just choose which one we want to use. Yeah, I don't know if this is just the housing, right? Like the plastic housing as opposed to plastic housing plus. All right. Could be that it just comes with this one, the OEM version. Which definitely looks like it's got different spacing than this one, which is the one that I think I sent to him. Yeah. I'm gonna look up OEM uh, OBD2 male connector. Yeah, that looks like it's too wide in order to fit around a PCB. Um, we may need to have to go with this one, AOT 1013. I'm gonna look up this with ODB. Nope, not ODB, OBD. My bad. It looks like we're gonna have to use one of their custom ones. Because at the end of the day, I don't think the OEM one that they offered is going to fit around a PCB very well. Like we're gonna need something like this in order to fit around an PCB. This is gonna be the one, I think. AOT 1013. If we want to use that housing. AOT 1013. Yeah. Min order one piece for $3. Your board's gonna have to be so thick. Or not so thick, but like it's gonna have to be a certain thickness in order for it to work. No. Well, that's my it's my email. I don't think anyone's watching anyway. It's not gonna matter. I need to turn on my light. Yeah. This looks like the one to go with. Like if you're gonna be I wonder how to make Google not give me those notifications. But I'll research that later. But yeah, looks like I did not get to do a whole lot of placement on this stream. It's pretty crazy how engineering just takes you from place to place to place. Doesn't let you focus on what you wanted to focus on. What does the inside look like? Like this, right? Yeah. Yeah, this is what we want. Yeah, enclosure OBD connector with case. $2.20. Bam. What are the dimensions of this? What is this? AOT 1145. AOT 1145. Yeah. All right. Versus the 121. Where's the 121? Yeah, this guy. Oh, we need the slots. Oh, never mind. Um, hmm. AOT 121. It's not that long, is it? I think it's probably going to be more like this. I don't see the exact one. The AOT 121A. But I just really hope that it has a very similar thing as this. And it looks like it, honestly, when you look at it like this. Nope, it doesn't. It doesn't have the leads going down and in. Yeah, that's gonna have to be clarified. Like, what connector does it come with? Oh, are these like adapters that go onto these? Is that what's happening here? I have no idea. Yeah, AOT121A. Right here. Um yeah, if we could get this connector, something like this, where it comes on and encloses around a PCB, that would be super ideal. And then you just design it that way. Yeah, AOT121A is what we need. All right, I think I'm gonna call it a wrap for now. Like, most of what I was doing is mostly just research today. Wasn't able to do much PCB design actually, but I mean, it seems like the entire layout is going to have to be rethought and redesigned in order to fit inside of a package. Um, so yeah, it's exciting though. It's exciting. Um, get to try to figure out how to get power, um, USB, and SIM card in. Uh, this looks like a debug version of this, honestly. Actually, I'm not even sure what this is. Maybe this is it for an antenna. Ooh, that could be for an antenna. Hmm. Hmm. That would be pretty cool. I mean, if they're anticipating a SIM card, then why not an antenna, right? So, that's pretty neat. If that's the case. Where's AOT121A? Like when you look at the housings, they all come with the connectors, but like, do we have to specify to them which one that we want? Does the price change with that? Look at this guy. AOT121A. So this one has no uh, outlet. So I think at the end of the day, when we designed this to actually go into a vehicle, it's going to be powered. I guess it might be powered by battery. In which case you want, yeah, if it's going to be battery powered, but you're plugging it into a vehicle. I guess the vehicle could be off. In which case you don't have power. But do you have power? Does OBD always have power? Yeah. Yeah, and we can go into some sort of sleep mode. So it looks like we have always got power for OBD. Like we don't need battery. That's what we're doing. Um, yeah, yeah. I guess for this iteration, like this is this tracker thing that we're doing. It's supposed to be able to do either be battery powered, right, with either cable charging or wireless charging, or powered from USB or powered from uh, CAN, right? But sort of the idea is that all these power modes are different configurations, right? And that it's really the same PCB, but different variants that allow all these different things. So, but if we're making a variant that's supposed to go into this housing, it's designed to plug into OBD, then you don't care, right? Unless you want the option of either like in the same module, like saying, oh, do you want it to be on? Oh, that doesn't make any sense. I don't know. What I'm thinking is that you have the option of like, okay, this one thing has not only the um, yeah, this one module, it can do both with either battery power or CAN power. But what does that gain you if you've already got an OBD port available? Yeah, if you're already packaging it into this case, then I don't think you need the ports. I don't think you need the slits, the openings per se, unless you really needed that. If that was an antenna output or antenna opening, if you really needed that, I don't know. I don't know. It's interesting to think about. It might be worth it for debug. I just really hope there's a way to specify what male connector you want, right? In terms of how it interfaces with the PCB. I really hope there's a way to do that. Um, all right. Well, that's gonna be it for me today. Mostly about researching. Um, Not too much layout going on. In fact, all we did was just disconnect things and move it just a little bit, and tried to fix a couple things with the schematic. But that's life. That's life. Sometimes you just got to take a step back and really think about what you're doing, right? Like this whole housing thing completely upends what we were trying to do, because now the board is now going to be mounted like this. It's not. And so, I mean, even if it were mounted like this, like imagine you had the housing, right, and this was more, because the ones that we were looking at, the PCB would be in the middle here and um, supported on both sides. But even if it were down here, there's probably still clearing inside the housing in order to allow maybe not something as big as this, but like these littler ICs to be on the backside, right? I mean, honestly, everything would have to be put on this side, right? Like the whole, it's entirely wrong, the side that this is on, honestly. Um, yeah, yeah. No, interesting stuff. Yeah, we're gonna have to think about what it is precisely that we want. I honestly think just get the housing that doesn't have the slits, right? Just make it pure CAN. And I mean, when you're debugging, when you got this on the bench or whatever, you don't need it in the housing. You just get something like this, like a spare one, and you just solder it in, and you have everything available. Um, That's what I would do. Yeah, but in production, you don't want things accessible, really. All right, all right. Well, that is that. Uh, Thank you all for watching, and I hope you enjoy. Let me see if I can do this. Control Alt 1 to get out of viewing, and yeah, that's it, guys. Thanks. Bye.